Good morning to all. My name is Chetan Karnar. Today we are discussing product design and development, unit number 4, concept and exploration. This is our syllabus: solid modeling of parts, product architecture, digital product design, DPD, design drawing definition, classification of engineering drawings, elements of product drawing, bill of material, types of dimensions, arrangement of dimensions, principle of dimensionings, limits, speeds and tolerance, geometric tolerance, datum stratum, design for assembly, design for manufacturing, design for process, product design steps, product to ergonomics in product design, design review, part print analysis. So we are going to next. This is our ESP as per the SPU previous year question papers. Uh, this is first part. So we are starting solid modeling and part assembly. So this is solid modeling is a 3D presentation of components using these CAD softwares like CATIA and SolidWorks or Creo. It helps visualize the conceptual shapes, volumes and mass of parts. Part modeling focus on individual components. These are the individual components, and this is assembly. Example: design a gearbox, housing and assembly gears, shafts and covering parts. Solid CAD solid model programs use a database of primitive forms of solid geometry like cubes, cones, cylinders, pyramids, spheres, etc. These are some information. This is assembly for solid modeling and part assembly. Product architecture. Product architecture means is how two function elements or product are arranged into physical building blocks. It describes the structure and interaction between parts. This is product and this is interaction between the these products models. Product modulars independent parts integral in architecture. Functions are tightly like. Suppose we have given example of bicycle has modular architecture. Handlebar. Suppose this is handlebar. This is seat. This is wheel or something like that. Chunk is the made of the collection of components that carries out various functions, sub-functions of the product. Other terms for chunks element that make up a chunk, subsystem, cluster, module, building blocks, interface. Architecture. Architecture is the product is the scheme by which the function element of the product are arranged into physical chunk and by which the chunk interact. And this is next part, product development process. In that, suppose we have given some planning, concept development, system level design, detailed design, testing and refining, and then the product ramp up. Means the platform decision. In planning, we have the platform decision given right now. Concept development, concept decision. Here we given the decision to the next part. System level designing, decomposition, product in product architecture design. Product architecture define how to function element of the product are arranged into physical building. These are the some parameters we are going through into physical building blocks. It describes the structure and interaction between parts. Modular architecture independent parts. Integral architecture functions are tightly like compact and complex. Example We are giving example. Bicycle has modular architecture, handlebars, seat, wheels, or all like that. Choosing the product architecture. These are the parts. Choosing product architecture. Architecture designs relate to product planning and concept development decision. Product changes, copy tuner, camera lenses, product variety, automobile or computer, standardization, motor bearing fasteners, performance, racing bikes, fighter planes, manufacturing costs, disk drives, resource, project management, modular integral architecture, modular product architecture. So this is we are discussing in previous slide. Taylor example. Taylor example. Modular architecture means we have this is the trailer and this is the parts. We are divide it into in different and this is same integral product architecture. Integral product architecture in that functions are tightly linked, compact but complex. These are the steps to establish product architecture. Create a functional module, cluster the define, sorry, cluster the element of the schematic. Third, make geometry layout to achieve the types of product variety. For identify interactions, fundamentals, incidents. Design for assembly. Design for assembly is the methodology was pioneered by Boothroyd and Dorhurst at the University of Rhode Island. The method is design evaluate to enable designers to product for easier manual or automatic handling in assembly, reduce the labor and time involved in assemble. Design for assembly is primarily a cost saving tool that is concerned that reduce the product assembly cost by minimizing the part counts. Means here part minimization is done. The number of assembly operations need to reduce the parts and make these assembly operations as easy as and fail proof as possible. DFA means design for assembly reduce the number of opportunities to fail in any assembly operation. This automatically leads to improve design and manufacturing quality as well as significant cost reduction. Here, here is a lot of parts, 24 parts, 8 different parts, and here is some 2 parts only. So here is a use design for assembly to reduce many parts. Here is a multiple manufacturing assembly process necessary. Here is one assembly step is done to assemble the parts. Here is the design for assembly principles. These are the some steps: minimizing part counts, modularity, building in fasteners, part part symmetry, mistake proofing, use standard parts, and use a reasonable tolerance. And standard parts means the there where we can consider all these aspects throughout the product development phase will ensure a lower overall manufacturing costs turn into increasing the potential revenue. Company makes good revenue from this because assembly was easy in design for manufacturing. It seems very much product centric. Many of these features will also appreciate an end customer. Design for manufacturing. Design for manufacturing ensures the product can be manufactured easily and economically. It considers processes capability, tooling materials and tolerances earlier in design. Example given to you. Avoid sharp internal corners. Hard to machine. Design for manufacturing and design for assembly are the integral products. Design and process planning into the common activity. The goal is to design a product that is easily and economically manufactured. The importance of designing for manufacturing is underlined by the fact that about 70% of manufacturing costs and the product. Here we are saving a lot of money. These are the some parameters. Reduce the total number of parts. Develop the modular design. Use of standard components. Design parts to be multi-functional. Design parts for multi-use. Design for easy fabrication. Avoid separate fasteners. Minimize assembly directions. Maximize compliances. Minimize handling. Design for process. Here is a chart. Design for process. In that, suppose we are giving to in simple words, every process has its own design consideration. Casting, forging, welding means that casting provide draft angle and fit fillets. For forging in that maintain grain flow directions. Welding ensures joint accessibility. This ensures process suitability and cost effectiveness. Process design steps. Here is just some steps for product design steps. Here is a brainstorming, defining the product, conducting the user research, sketching prototype, and problem identification. First of all, market research, concept generation, concept selection, modeling and simulation, prototype development, testing and design review. So, final product and documentation. These steps convert idea into real parts. In product design steps, we are convert the idea into the real parts, real product. Sorry, product design program. Product design process. Discuss with clients, market research understanding, define create product briefly, sketch ideas, create visual renders, conceptualization, developing concept, define design, 3D printing. Here is a prototyping with 3D printing, testing, and here is the manufacturing last part. Introduction of ergonomics in product design. Ergonomics is the process of designing or arranging workplaces, products, and systems so that they fit in people who use them. Most people have heard the ergonomics and think it is something to do with sitting or with the design of car controls and instruments, and it is, but not so much that. Ergonomics applies to design and anything that involves people's workplace, sports, pleasures, health, and safety. So we are something. Ergonomics deal with the human efforts, human comforts, safety, and usability in design. It ensures the product fit the user's physical and psychological needs. Example: adjust the stair height, grip handle tools, or dashboard design for easy reach. How to ergonomics works? Suppose we are giving the example of the chair. Height is adjustable, grip friendly tool, or dashboard design for easy reach. Something that body size, shape, population, and variety. Biomechanics, environmental physics, applied psychology, or social psychology. Ergonomics aims to create safe, comfortable, and productive workplace by bringing human ability and limitations into the design of the workplace, include the individual's body size, strength, skill, speed, sensor ability, and even attitudes. We are here. We are giving you the example of chair. Here is an adjustable chair, grip standly, Here is the inspection position, means the final output is a comfort. Comfort is a ergonomics in product design. Design review, part print analysis. The ideas of product design and convey to the concern with the transforming them into physical product using part drawing, blueprint, part prints. Suppose we are giving design review, means evaluating the product design for performance, safety and manufacturing before final approval. Part print analysis involves checking dimensions and tolerances, surface finishing, material suitability, machining feasibility. This ensures error-free and efficient product. The process engineering must consider the following two important questions in making his primary part analysis. What does the product design wants? What must be done with the information disclosed by the part print to get what we want? The general description of the part, the general configuration of the part, the material from which the part is made, how the part originated, recorded changes in design, resistance to damage in process. Here is the planes, planes 2D design. Classification of engineering drawings, elements of product drawings, bill materials, types of dimensions, arrangement of dimensions, principle of dimensionings, limits, fits, tolerances, geometric datum system. Limit. Limit means the maximum and minimum permissible size of the part. Limit means was maximum and minimum permissible size of the part. Tolerance. Tolerance means the difference between these two limits, means indicate allowance variable. Fit means what? Relationship between two mating parts, holes and shaft. Clear in here fit three different clearance fit, always losing, bearing on shaft. Transition fit may be tight or loose. Interface fitting always tight. Example press fit. So finally, conclusion of our this unit to product design is a combination of creativity, engineering, and manufacturing knowledge. Our design must be balanced, function, cost, manufacturability, and user comfort to create a successful product. So thank you.